Okay, now we're ready to put some specific tolerances. So you'll notice, in 7.2 we just did the section view with chain dimensioning. We had some vocabulary practice on the hole types. Now I'm just created a second copy of my section view of the drill block, and I've already started it dimensioning it. If I look ahead a little bit at what the directions are telling me to do, I know I'm going to include most of those dimensions, but I want to do datum dimensioning instead of baseline dimensioning, and that's going to better control the hole locations. And this is one of the reasons that datum dimensioning is usually preferred over chain dimensioning, and we'll talk about that when we get towards the end of this lesson. So the first thing we want to do for overall length, width, and height, we're going to put a bilateral tolerance symmetric of 0.10 inches on the overall length, width, and height. So let's see, I'm on the wrong file. So that means overall length, width, and height, and then we're going to use datum dimensioning as well. So I guess let me do the datum dimensioning for all the holes first. Just click all my center points. Of course, I've already used the center point tool to create those. Whoops, one more. Baseline. Click all my center points. And that brings in all the baselines. Now, overall length, width, and height, we want to do, let's read the directions again, a bilateral symmetric tolerance of 1/10 of an inch for overall length, width, and height. So what we're going to need to do on each one of those, I go in and edit the text, go to precision and tolerance, and we're going to add a symmetric tolerance that is 1/10 of an inch. So that's 5 plus or minus 1/10 of an inch for the overall width. Again, that's symmetric, 1/10 of an inch. Now you'll notice when that starts to run into other numbers, now it's perfectly acceptable to slide it up so it's not in the middle. And then we've also got to do this one here. Edit, make it symmetric. Okay, so we're good there. What are we supposed to do next? Next, it said to do a stack limit dimension along the depth so that the dimension can vary above 0.03 inches larger. So that's talking about the 1-inch dimension, okay, which I did before, 1.03 to 1. So how do we do that? Okay, same way we did that, we're going to right click that, edit the text, edit there, and it's going to be a stacked limit, and the upper can vary and go up to 1.03. Okay, so there's our limit dimension. And we already did the baseline dimension. Now they want us to add some specific tolerances to the holes. So of course, before we can do that, we're going to need to do all those hole notes again. So of course that's simple to create those. One of the things, looks like this title is going to end up in the way, so I'm just going to drag that and move that up here. hole note. And we already know that 0.375 on the counter bore diameter needs to be 3. So I went into the hole note precision and tolerance and changed that to 3 decimals precision. Okay, let's read what the specific tolerances we're supposed to add to some of the other holes on this block. Supposed to add 2 specific tolerances to the holes, a unilateral tolerance of 0.03 inches for the counter bore diameter on the 20 1/4 inch hole, 0.25 inch hole. And of course you got to show 3 decimals, 3 decimal places on counter bore diameter. So counter bore diameter on the 1/4 inch hole, that's this one. That's the 1/4 inch hole, because the other counter bore is a 1/2 inch counter bore. So we already changed that to 3. Let's see. So let's edit that hole note again. Precision and tolerance. Let's see. How am I going to add the tolerance? Now, let me pause the video for a minute here. Okay, to do the precision and tolerance, I got to go to precision tolerance, and there's this little more button. I got to open that up, and then I'm changing the tolerance of the counter bore to be unilateral, which, what's that going to be? A max. A deviation. A deviation is what it's going to allow us to do. A deviation of my upper 0.375. 0.378. Oh. Alright, let's see what the next one is. The next one we want to do is put a unilateral. Now in Inventor that's called a deviation, that goes plus 0.03 of an inch to the counter bore diameter on the 1/4 inch hole. And of course we have to show 3 decimal places. I think we already did the show 3 decimal places. So if I edit this hole note and I do the precision and tolerance, okay, when we first open this up, this is what we see. We already changed this to 3 decimals. And what we need to add to that is that we're going to change this to a deviation of 0.03 of an inch. And of course you have to also make that match the precision at 3 values. So it can be 0.03 bigger, not smaller, and that will list it as a unilateral deviation. So I say OK. Say OK, and there's my unilateral hole note. What do I have next? Next, we're supposed to put a bilateral tolerance of 0.02 of an inch on the 1/2 inch diameter countersink hole. And this time it's describing we're putting 0.02 on the diameter of the hole. So we're going to have to figure out where that is. So if I edit my hole note, do my precision and tolerance, of course I need to uncheck the global precision, and the diameter, what are we changing that to? 2/1000 of an inch. And we might need to make that 3 decimals. I don't know, I guess we'll see if it works, and we can always change it. Yeah, we have to make that 3 decimals. Edit the hole note, precision tolerance. So in order for that to show up at 0.002, in fact it totally rounded that off, we have to tell the precision to go 3 decimals. Okay, so now it's plus or minus 2/1000 of an inch on the counter bore diameter, which that's, or on the diameter of the hole, the 1/2 inch, not the counter bore. Okay. Next, what are they asking us to do? Next, they're asking us to add a general tolerance note. So the easiest way to do that is just do a text box. That's fine. So of course that's just a text box X. So we would do general tolerances. We actually are supposed to use all caps when we're doing text on drawings. I'm in a bad habit and sometimes I forget that fact, but general tolerances. Of course, I think if we have 1 decimal place, then it's supposed to be what, 20 plus or minus 20 thousandths. To get that plus or minus, there's a symbol tool somewhere. Where's the symbol tool? Oh, here's the symbol tool. Plus or minus 0.020. If it's 2 decimals, it's plus or minus 10 thousandths. 3 decimals is plus or minus 5 thousandths. And somewhere in there we should probably space those so that everything lines up nice and neatly once we know how far across we want to go. Makes it nice and neat and easy to read. And then an angle is plus or minus 1/2 degree. Of course, we want that to be on our drawing somewhere where it's easy to read. Of course, this drawing that we just did, this is baseline dimensioning. Okay, now the next question we're supposed to consider is in the drawing that used chain dimensioning to locate the holes. therefore, and the holes are going to fall under general tolerances, we have a whole bunch of, we have 1, 2, 3, 4. There are 4 different dimensions that each one of those could be plus or minus 10,000ths of an inch difference. Each one of those could be plus or minus 10,000ths of an inch. So that becomes a little bit additive. So that would mean if we would use all the lower limits could go anywhere from 0.74, and the lower limit on the other one would be 0.99 to 1.24, and then that last one also 1.24. Okay, so that would be all the lower limits for the position of the hole from the left side of the block, which, let's see, I'm not sure what that adds up to. I'll find out in a second. And if they're on the upper limit of what's allowed by that tolerance, of course, it's 0.76 plus 1.01 plus 1.26 plus 1.26. And let me pause and get a calculator and figure out what that's going to be. Okay, with the chain dimensioning, I got my calculator out. That means that if every hole was on the minus side of the dimension specified, which would be acceptable by the drawing, that would be at 4.21 inches from the left side. And if every hole was on the positive side of what's allowed by the chain drawing, then that hole could be at 4.29 inches. So that's a total, of course, that's a total allowance of 0.08 of an inch. That's a tolerance of 0.08 of the position of that hole. So I think what they ask us to add that is that's the upper and lower limit of the dimension. So assuming that those general tolerances apply, when we're on the chain dimensioning, let's go ahead and add one more dimension. Again, this would be could be a significant difference. The upper limit 4.29, the lower limit 4.21. So that's, you know, a significant difference in the position of that hole. If all those holes are trying to line up and they're off that much, now you're talking about your nightmare dollhouse that you're trying to put together on Christmas Eve. On the other hand, and again, that's because the tolerances build up with chaining. On the other hand, if you put if you do datum dimensioning, what's allowed by the general tolerance note is 1,000ths of an inch difference. So of course that's, I think, what the next question asks about. Oh, and I don't have this in this drawing. It's page 4, and I don't have it in my document right here. But what the following question asks is, well, what about this dimension? This dimension, if it's only different by 1,000ths of an inch, of course the upper would be 4.26 and the lower would be 4.24. So that would be that limit dimension. That's all for 4.2. At this point, what we'll want to do is of course, to get this to print out nice and neatly on the printer, we're going to export this drawing to a PDF, and when we print it, there's the drill block. When you go to print the drawing, you're going to want to make sure that when you go to the print option, you're going to need to fit it to the page to make sure it'll fit on your 8.5 by 11 paper, because this is 11 by 17. Alright, very good.